Yeah, thanks for the introduction. As you heard, my name is Dominik. I work at the Law Center in Graz, Austria, and this is joint work with Gregor and Elisabeth from Graz University of Technology and Markus from Johannes Kepler University in Linz, also Austria. Okay, starting with the motivation of this work, I think we can all agree that recommender systems are quite useful tools that help us finding information. But related research has also found that there are some issues. For example, that they suffer from an inconsistency of recommendation performance across different user groups. I have two examples here. The first one is the varying recommendation accuracy across different user groups, which could lead to unfair treatment of users whose preferences are not in the mainstream of a community or of a system. And the second one is the inconsistency between the input data of a recommendation model and the output of this recommendation model, so the generated recommendations, which could lead to recommendations that are either popularity biased. We can measure this with metrics such as the popularity lift metric, or that do not match the interests of a specific user. We can measure this with metrics based on calibration, like the miscalibration metric. And in this work now, we want to look at these different definitions of inconsistency. And in the first objective, we want to see if they are correlated somehow. And in the second one, we want to inspect this recommendation inconsistency for different genres. So in the first one, we look at the user level, and the second one more on the genre level. Okay, before starting, we need some more formal definitions of inconsistency. For the different metrics that I mentioned. The first one are simply accuracy differences between different user groups. We can do this by measuring the mean absolute error, for example, in rating prediction tasks. So the lower the value, the better. Or we can use metrics such as recall and precision for top N recommendation tasks. And here, the higher, the better. Then this miscalibration metric I mentioned, we could measure this by using the Kullback-Leibler divergence between genre distributions in the input, so the user profiles, and the output, so the genre distributions in the recommendation lists. And based on the given equation, a value of 1, that means totally miscalibrated recommendations. And the value of 0 means perfectly calibrated recommendations. And then finally, we have this popularity lift definition, which we can calculate by comparing the group average popularity of a given user group between the profiles of this group, so the input, and the generated recommendations of users within this group, so the output of the model. And based on the definition, a positive value for a group means that the recommendations were popularity biased, and the negative value means that they were too unpopular, given the input data. And the value of 0, again, is a perfect score here. So looking at the data sets that we used, so we built on 3 data sets that we already used in the previous work that we also presented last year here in this workshop. But this time we extended them with genre information because we need them for this miscalibration definition. In case of Last.fm, this music data set, we needed to do this genre mapping by our own. And here we mapped user-generated text that users in Last.fm applied to music artists to the all-music database to get the genre information. And then for the other 2 data sets, so MovieLens and MyAnimeList, the data sets or the original data sets already come with genre information, and we just need to map them to the given items. And then again, we split the data sets into different groups or user groups that differ in their inclination to popularity. So we have a low popularity group, we have a medium popularity group, and a high popularity group. And each group contains of 1,000 users, so they're equally sized. And yeah, as you see from the dataset statistics table, then all dataset samples that we use consist of 3,000 users. And given the number of ratings, Last.fm is our largest one with around 1.5 million ratings. And all these dataset samples are also shared via Zenodo. So if you want to reuse it, they come with the user group definitions, the splittings, and of course also the genre information. So now how we have calculated recommendations and how we have evaluated them. We used the surprise framework, which is a recommendation framework implemented in Python. We did rating prediction in case of Last.fm by predicting the listening counts of a user for a given artist, because we don't have explicit ratings there. And we calculated the top N recommendations in this case by predicting the top 10 items with the highest predicted ratings. We used 5 different recommendation algorithms, a rating prediction-based approach, 2 KNN-based approaches, non-negative metrics factorization, and a scalable co-clustering-based approach. The evaluation protocol was a random 80-20 train test split in a 5-fold cross validation manner, and we tested for statistical significance using pairwise t-tests between the different user groups in the dataset. And we also share the whole pipeline, the algorithms, and the result generations in our GitHub repository that you also see here. Okay, coming to the results. For the first objective, where we compare the accuracy with miscalibration and with popularity lift for the different user groups on the 3 data sets and the 5 algorithms. And we see that in all the cases, the low popularity group always gets the least accurate recommendations. And this is also aligned with miscalibration. So in these cases, also the low popularity group gets the most miscalibrated recommendations and the most popularity biased recommendations. There's just one exception, namely in the case of Last.fm for this popularity lift metric. So we further investigated this by looking at the fraction of popular items in the different user profiles for the different user groups, which we see here. And in case of MovieLens and MyAnimeList, this makes perfect sense. So the user groups are clearly separated. And the high popularity group, as expected, has the highest fraction of popular items in the user profiles. But in case of Last.fm, we see that the user groups are mostly overlapping. So this means that in Last.fm, also the low popularity users sometimes listen to popular artists. So they also have popular artists in the user profiles, but they mainly listen to low popularity artists. And this is not the problem of this popularity lift metric, because it does not account for these repeat consumption patterns. So it does not matter if you listen to an artist 1 time or 1 million times. For the metric, it's the same weighting. So it's an unweighted metric. Now coming to the second objective, so recommendation inconsistency in terms of miscalibration on the genre level. And here we see strong fluctuations over the different genres, which means that indeed different genres are contributing differently to inconsistency. But we see one quite interesting spike here at the bottom. So for the hentai genre in anime that you may know. So here we have a very high spike for the low popularity group and only for this group. So it's hard for the recommendation algorithms to calibrate correctly for this genre for these users. And we also looked into that by plotting the number of ratings over the different genres and also the number of users for the different genres. And again, if you look here at MyAnimeList for the number of users, we again have a quite a large spike, so a large degree in number of users interested in this hentai genre, but this time for the medium popularity and high popularity users. So this means that this hentai genre is only interesting for these low popularity groups, And because of this, it's also hard for this mostly collaborative filtering-based algorithm to exactly calibrate for this genre, for these users, and to provide meaningful recommendations in this case. Okay, summing this up, so we found that these low popularity users get the least accurate recommendations, the most miscalibrated one, and most popularity biased ones. So in general, all these three metrics are aligned. And we also found that particular genres contributes differently to the inconsistency of recommendation performance. And this is especially given for this hentai genre for the low popularity users. Future where we want to use these insights for developing popularity bias mitigation strategies. So for example, we can make calibration-based debiasing for genres that highly contribute to miscalibration. So this hentai genre, for example. And we could also do personalized re-ranking for users of user groups with a high popularity lift. So in general, these low popularity users. Then, of course, we need to work on some definitions, some metrics. So if we've seen this popularity lift metric does not work in this Last.fm case, where we have repeat consumption patterns. So we need some form of a weighted popularity lift metric. So this is also something that we want to investigate. Yeah, and of course, look in other domains. So this now in this paper, we only looked at these media domains or movies, animes, and music. But we also want to look at e-commerce, for example, and of course, on more algorithms, so more novel ones. Okay, thank you very much. Here again, you see the links to the paper, to the dataset, to the code, if you want to reuse it. And on Tuesday, we also have a demo on the recommendation framework. So if you're interested in also visit us then at the demo booth Tuesday afternoon. Thank you.